All right, let's talk about OFDMA. It's really the secret sauce that's making our modern Wi-Fi networks so much faster and way more efficient, especially when things get crowded. You know the feeling, right? You're at the airport, maybe a packed stadium, and your Wi-Fi just slows to an absolute crawl. It's infuriating, but this isn't just a random annoyance. It's a really fundamental engineering challenge called network congestion. So how do we actually fix it?
Well, to solve this puzzle of fitting more data into the air, engineers basically have two main tools in their toolbox. First, figure out how to share the radio spectrum efficiently, because, it's a limited resource. And second, find a way to pack as much data as humanly possible onto every single signal that goes out. Let's break down what those two things actually are.
Okay, so first up is multiplexing. The best way to think about it is like a super efficient carpool system, but for data. It's the art of combining a bunch of different signals from different people into one, so they can all share the same highway, the radio frequency, without, causing a massive pileup.
And then there's modulation. So if multiplexing is about sharing the road, modulation is about how much stuff you can cram into each car. It's this really clever process of taking our digital ones and zeros and encoding them onto an analog radio wave. The better your modulation scheme, the more data you can squeeze in. Simple as that.
All right, so with those two key concepts in mind, let's talk about the technology that was the workhorse of Wi-Fi for a long, long time, OFDM, or orthogonal frequency division multiplexing. This thing was a huge deal when it first came out.
So the real magic of OFDM is this idea of orthogonality. What it does is it takes a big, wide radio channel, say 20 megahertz wide, and slices it up into hundreds of tiny little subchannels. They're called subcarriers. And because of some really clever math, they can be packed right next to each other. I mean, incredibly close, without interfering with each other. It was a massive jump in how efficiently we could use the airwaves.
To put that in a real-world context, think of an OFDM system like this. You've got this huge delivery truck, and it gets the entire highway all to itself, just to deliver one big package to one single house. It's great if you have a massive delivery, but the key thing is only one person gets served at a time.
Now that whole single truck, single package thing works just fine if you're streaming a 4K movie, but it leads to a really big question. What happens when the package is super tiny? Like, say, a 100-byte update from an IoT sensor or your smart thermostat just checking in.
And that right there is the fundamental flaw of OFDM. You're still sending that entire massive truck, the full channel bandwidth, to deliver this teeny tiny little packet. The result is just absurdly wasteful. Almost all of the truck's capacity is empty. This is what we call spectral waste, and in today's world with billions of connected devices, it's a recipe for disaster.
So this exact problem, this massive wastefulness, is what OFDMA was born to solve. And it's not just a minor tweak. OFDMA, or orthogonal frequency division multiple access, is a totally different way of thinking. It's a fundamental shift from a single-user system to a multi-user one.
Yeah, this table really lays it out perfectly. With OFDM, it's one user at a time. The whole channel is theirs. But with OFDMA, which you'll find in Wi-Fi 6 and 7, you get multiple users on the channel at the same time. Instead of a fixed resource allocation, it's dynamic. It carves up the channel into little pieces for different users. The bottom line? You get way higher efficiency and much lower latency, especially in those high-density places we were talking about earlier.
So how does it actually do this? What's the secret? Well, it's all about something called a resource unit, or an RU. The access point acts like a super smart traffic controller. It takes all those little subcarriers and groups them into these blocks, these RUs. If you need a ton of bandwidth, you get a big RU. If you're just an IoT device sending a tiny blip of data, you get a tiny RU. It's perfectly customized.
Okay, let's go back to our delivery truck. With OFDMA, instead of one truck for one package, it's a whole new game. The system is now smart enough to pack that same truck with tons of different packages. Big ones, small ones, all shapes and sizes. For lots of different houses, all in one single trip. See? No wasted space. This is the core idea behind OFDMA's efficiency.
But of course, technology never sleeps, right? Even this awesome new system had a limitation. And that's what brings us to the very latest standard, Wi-Fi 7.
So, with Wi-Fi 6, which is where most of us first got OFDMA, there was this one strict rule. An access point could only give a single resource unit to any one client at a time. So what happened if you needed a little more bandwidth than one RU could offer, but not enough to justify the next bigger size? Well, tough luck.
Any empty RUs right next to yours were just wasted. The system couldn't combine them. Wi-Fi 7 comes along and just smashes that limitation with something called multiple resource units, or MRUs. This is a game changer. It gives the access point incredible flexibility because now it can assign multiple RUs to one person, even if they're not connected to each other. It can basically stitch together these leftover bits of the channel to perfectly fit what a user needs. And you can see the difference so clearly right here. On the left, that's the Wi-Fi 6 world. The user gets their RU, but those smaller ones next to it, they're empty, just wasted potential. But now look at the right. That's Wi-Fi 7 with MRUs. The access point is smart enough to give that same user their main RU and those smaller ones. Suddenly, all that wasted space is being used. It's so much more efficient. And the result of this? It's pretty incredible. In some situations, this little trick boosts how much of the spectrum we're actually using to almost 98%. That is a massive, massive improvement in squeezing every last drop of performance out of the airwaves.
Okay, so OFDMA is not just about raw speed. There are some other really cool, less obvious benefits. But it's not a perfect solution. It also brings a whole new set of really complex problems that engineers and researchers are trying to solve right now.
One of those benefits that people don't talk about enough is power savings. Now, OFDMA by itself gives you a little bit of a boost, maybe 3%, just by cutting down on how often devices have to fight for attention. But the real magic happens when you pair it with another Wi-Fi 6 feature called Target Wake Time, or TWT. This lets your devices literally schedule when they're going to wake up to talk to the router. The result? You can save up to 90% of your battery. For IoT devices, that's absolutely huge.
All right, but now for the hard part, the challenges. Because making OFDMA work perfectly is really, really tough. The brain of the whole operation is the scheduling algorithm in the access point. And if that algorithm isn't smart, things can go wrong. In fact, some of the early attempts actually performed worse than the old OFDM systems. The scheduler needs perfect real-time info about the channel, which is impossible in the real world. You've also got this weird paradox where in a network with tons of tiny IoT devices, the effort of scheduling all those little packets can actually wipe out the efficiency gains. It's a super active and fascinating area of research.
But even with all those challenges, the real-world impact is undeniable. This study here says it all. When you switch from that old, random, everyone shout at once system to the scheduled, deterministic world of OFDMA, you see things like a 37% drop in latency and a 20% bump in throughput. It really does transform the network from total chaos into a well-run, centrally managed system.
So this kind of leaves us with one last big idea to chew on. With OFDMA, the game has changed. The challenge isn't just about sharing the air anymore, it's about scheduling it with real intelligence. So what happens next? As these scheduling algorithms get supercharged with AI and machine learning, what happens when our networks stop just reacting to our needs and start predicting them? That's the really exciting future that OFDMA is paving the way for.